What's up, everybody? Welcome back to another live stream from Scalar Learning. And again, if you are not new to the channel, hopefully you've seen that I got a new schedule up that we started in the new year. If you are new to the channel, this is the schedule. Every Wednesday, I'm going to be doing ISEE related material. The ISEE is the Independent School Entrance Exam. It stands for Independent School Entrance Exam. Okay, a lot of people in California, for example, take the ISEE to get into different prestigious private middle schools, high schools, even lower schools, and they're all different levels. So in Los Angeles, I work with a lot of students that have to take the ISEE, and the one that they take most frequently is the middle level. Okay, the middle level is for people applying to 7th and 8th grade. So you're usually taking this test in 6th grade, sometimes 7th grade. It's a very difficult exam because especially most of the students that I work with take it in 6th grade, and if you're competing against 7th graders, it's hard. And there's a lot of material on the test that's difficult. It is basically pre-algebra, borderline algebra, and it can be quite difficult. So it requires a lot of preparation. And today, what we're going to be doing, or every Wednesday going forward, is we're going to be working on middle level ISEE, quantitative reasoning, and math achievement problems, which those are the two math sections, and realistically, they're pretty similar. The quantitative reasoning just has an additional section, which I'm going to show you today, called quantitative comparisons. So what we're going to do is I just took screenshots. Now this is, what we're going to be going over is a sample test that is released by the ERB. Now ERB is the organization 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. ERB is the organization that makes the ISEE. Okay, so they are the ones that create this test, and we are they only, unfortunately, have only released one practice test themselves. And so this is kind of what we have to go with. Now, there's a lot of amazing resources. I, too, have a video course of course, myself that I've made for the ISEE, for the middle level ISEE math portion, which I will definitely send along to you guys if you want to check out. It's a video course on Udemy plus a bunch of additional practice problems. But this is always what I have people start with when they're getting familiar with the test, because it's straight from the source. Now remember, anytime we think about test prep, we want practice materials initially straight from the source. We want to exhaust those before moving on to supplementary materials. And there's another amazing resource called ISEEpracticetest.com. It's not an official, it's not officially affiliated with ERB. 1, 2, 3, 4. It's not officially affiliated with ERB, but it's got great practice problems, really well tailored to the material that you'll find on the practice test or what you'll see on the real thing. 1, 2, 3, 4, 5. All right, so you can kind of see I'm laying this out. Now, usually, I always love to take these tests. I am going to do it in real time today, meaning I'm going to start a timer and I'm going to work through every problem like that. But in this case, since they have not released any additional practice tests and they've kind of dropped the ball on that for whatever reason, I'm doing the test that I've seen so many times over the last several years. So I'm going to be doing, so it's not really for the first time, but I will take it under time conditions. It's been a while since I've really gone through and sat down and solved all the problems. So hopefully it'll still give that similar effect, but we'll see. Now here, what I just loaded is the quantitative comparisons page. So again, I'm going to talk about that when I get there. Okay, and this sample test is not the full length of the real test. It's a little bit shorter, all right, but still very similar to what you're going to be seeing. I took the real middle level ISEE in, I think it was 2016, that summer. Like, I took an official one to get the feel for it and really understand the entire process. The other good thing, the great thing actually about this test is you can take it on a computer at a Prometric center, and I definitely recommend that to all my students if possible. So that's definitely a great option. Okay, so now we've got all the pages up, and we're going to solve it on this document up here. Okay, and we'll zoom in a little bit. I think that's good. I always leave spaces in between here to manipulate this and move this. Okay, let me double check the time that we have for this test. I think it's normally like 40 minutes, but this is something like that, but it's a little shorter. 30 minutes, okay? 32 questions, 30 minutes, so it's about a question per minute. Here we go, and I'm going to set it at 30 minutes. No calculator, by the way, for this test. Never a calculator on any of the ISEEs, so keep that in mind. Are we ready? Let me make sure we're good to go. No questions. All right, cool. Ready, set, begin. Okay. So first of all, graph shows the total rainfall for 6 months. According to the graph, what is the mean monthly rainfall? So we got to figure out these values. So look, mean, we take all of these and we add them up. So we got 7.5, right? That's 7.5. This is 4. This is 6. This is 9.5. This value here is 10. And this value here is 8. That's right. 8. I'm just reading straight across. Boom. So we take the mean, we got to add these up and divide by 6. So 7.5, 11.5, 17.5, 18. Then plus 9 is 27, 37. 37 plus 8 is 45. 45 divided by 6 is 7.5. Okay. So 7.5 times 6 is 45. So there we go. Okay, next. A set of 7 numbers. Okay, these are really important problems. A set of 7 numbers has a mean of 9. Okay, so a set of 7 numbers. So look, check it out. Would be like the sum of 7 numbers equals 9. So the sum of, so these numbers all add up to 63. That's why I just got there as the total. This is how we do mean, is we do total divided by number of terms equals the mean. And in this set, to create a set with a new mean that is 3 less than the mean of the original set. So we take this 63, we're adding some new value to it. Now we're over 8, and we want a new mean that is not 3 less than this, which is 6. That's a pretty big drop. Now we isolate and solve. 8 times 6 is 48. So we got 48 equals 63 plus x. Subtract 63. Subtract 63. 48 minus 63 is negative 15, I believe, right? 10 and 5, yeah, negative 15. There we go. Number 3. Bill has 10 coins, all of which are dimes and quarters. If his dimes were quarters, his quarters were dimes, his coins would total 30 cents more. Okay, how many quarters does he have? So he get like 10 coins, he could have 5 quarters and 5 dimes. That's a possibility, something like this. So usually when we're talking about 30 cents, like, look, every time I shift this one up and shift this one down, I'm changing by 15 cents because this would go up by 25, down by 10. So I'm going to show you, I remember this problem, but it's basically like if we have 4 quarters and 6 dimes, okay, that's 60 plus $1, that's $1, 60. And then if I have 6 quarters, okay, and 4 dimes, I know this is going to be a difference of 30 cents. That's 6 times 25 is $1.50 plus 40 is $1.90. Okay, check it out. I found the difference where the two values are flipped, where my number of quarters becomes the number of dimes becomes the number of quarters. And I see a differential in the 30 cents. So if we switched, we would have 30 cents more. So if we go down here, we'd have 30 cents more. So then we're right here. We're in this spot. Currently, the top one. So how many quarters does he have? He has 4. Okay, it's a hard problem. Now let's go to page 2. Okay, there are 7 same-sized pool cups. Plants with water will be used for watering plants. Fred used 1/3 of each cup of water. Janice used 1/4. Approximately how many cups of water remain? So look, check it out. 1/3 and 1/4. If we add them up, right, this is 3/12 plus 4/12 is 7/12. So 7/12 is what's been used, which means 5/12 is what remains. Okay. And if we know it's 5/12, now we go 5. How many cups of water remain? 5/12 times 7. Okay, and that's our total. So that's 35 over 12, which is approximately 3, right? If it was 36, it'd be 3. Exactly. So it says approximately, and I'd say 3. The area of the rectangle is shown as 96. The area of the entire rectangle is 96. What is the area of the shaded region? Well, 96, let's split it up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each one of these squares, if I divide 96 by 12, I get 8. Okay? So each one of these is 8, 8, 8, and so on and so forth, which means this is also 8, and that's the shaded region, so it's 8 centimeters squared, right? Next, which number is close to the square root of 150? The way I do this is, well, I know that 12 squared is 144. I know that 13 squared is 169. Those two fit right around 150. So it's gotta either be the square root of 150 is between 12 and 13, okay? Because square root of 144 is 12, square root of 169 is 13. This is closer to 150, so it's closest to 12, and 13 is not even an option. So we know that's right. We got cubes that are proportional. The volume of this guy's 8, volume of this guy's 64. What does that mean? Well, we need to figure out, we want the ratio of the side length. So what is a side length? Well, to get to a volume of 8, remember it's length times width times height. It's cubed, so they're all equal. So I'd say 2 by 2 by 2, because 2 by 2 by 2 times 2 times 2 is 8. And this one's going to be 4 by 4 by 4. I'm taking the cube root, because 4 times 4 times 4 is 64. So what is the ratio of the side length of figure 1, which is 2, to side length of figure 2, which is 4? Reduce that like a fraction, it becomes 1 to 2, which is D. Next, Joey has a new system of currency using coins, stamps, and chips. The values are shown below. Joey is paying his friend 12 chips. How many stamps is this worth? So look, 12 chips, if I multiply this bottom equation, the whole thing by 4, I get 12 chips equals, and then 4 times 2 is 8 coins, okay? So then I go to this equation up here, and I want to know how many stamps is 8 coins. So I multiply this equation by 8. And I get 8 coins equals, distribute that 8 over here, equals 16 stamps. So it's 16. Next. Okay, using the line of best fit, what is the average cost of a single item when 60 items are ordered? Here is my 60 line of best fit. We got to use this point right there. And it looks like if we come across, it's about 450. But this is the total cost of the order. We want the average, because this is a really tricky one. Average cost of a single item. Well, if it's 450 total and this equates to 60 items, we got to divide 45 by 6, which is 750. 7 times 6 is 42. Half of that is another 3 to get you to 45. 7.5. If 4y minus 1 equals 7, then 8y minus 2. Here's a trick, right? If I multiply 4y minus 1 by 2, I can multiply this entire equation by 2. And I get 8y minus 2 equals 14. I have to double everything, and I'm allowed to do that. And so that means this guy equals 14. A population of 42 fruit flies is increased by 150%. What is the total number of fruit flies after? Very important. Increased by. So first, like if that said 50%, I'd have to take 50% of 42 and then add that on to 42 to get the total. So in this case, I have to do not 50%, but 150%, which is multiplied by 1.5, okay? Remember, we convert a percentage to a decimal. We move the decimal 2 spots over, 1.5, and then multiply. And then we get 10, carry the 1, 21, 0, 2, and 4. And we get 0, 3, 6, and then 1 decimal, so 63. So that means 63 added on to the original of 42, which is 105. Okay. Number 12. Linda is performing an experiment using a random number generator. For each trial, the computer selects a whole number from 1 through 10. What's the probability that the whole numbers selected on the first 2 trials are both greater than 4? So look, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Both greater than 4. So it doesn't include 4, but that means 1, 2, 3, 4, 5, 6. So the probability of each one is 6 out of 10. 6 out of 10. What is the probability that they're both greater than 4? We take the individual probabilities of each event and multiply them. First, this can be reduced to 3 over 5, and that could be 3 over 5. Multiplies together, you get 9 out of 25. Okay. So we've done about 9 minutes and 12 problems. We're doing okay for time. The polynomial, the pattern shows can be folded into a polyhedron. Look, real quick, I already can tell it's got 1, 2, 3, 4, 5, 6 rectangles. This one has 1, 2, 3, 4, 5, 6 rectangles, and then 2 hexagons on top. That's a pentagon. It's got to be C. Matching up those sides. 14. A teacher awards test points according to the pattern in the table. A student scored 128 points. How many answers did he provide? Correct answers did he provide? Let's follow the pattern out. So 1 is 2, 2 is 4. Look, it's doubling every time. 8. Next would be 16 for 4. Next would be 32 for 5. Next would be 64 for 6. Next would be 128 for 7. The larger cube was built using smaller cubes. How many small cubes were used to build the large cube? Okay. So check it out. This is how I like to do this one. I look at this kind of slice here, and I can count the cubes in that slice. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then how many slices like that do I have? I have 1, 2, 3, 4. So 4 times 16 is 64. Okay. Boom. You could also do 4 by 4 by 4 to calculate volume as a volume calculation, but either work. Swim team buys sweatshirts for $12 each with an additional 5% sales tax added and then a standard shipping fee. The table gives the total cost including shipping fee for 4 separate orders. What is the shipping charge per order? So check it out. One sweatshirt costs $12 plus a 5% sales tax. So we need to calculate the sales tax. So remember, 5% to convert it to a decimal, move it over twice, 0.05 times 12. And we go 10, carry the 1, 5 is 6, move it over 2 times. So the tax is 60 cents. So we're paying $12.60 without the shipping charge. So the shipping charge must obviously be $4 because that's the only way that a sweater can cost $16.60. So the shipping charge is $4 per order. And that makes sense. Here it would be 48 plus whatever the 5% is would be 240, 50, 40, and then it'd be 4. Now you can figure it out. You can double check, but you only need to do it for one of these rows. On Monday, a student tells a secret to 3 people. On Tuesday, each of those 3 friends tells to 3 more people. 1, 2, 3, 1, 2, 3, 1, 2, 3. The secret is repeated in the same pattern until Sunday. So this is happening on Monday. This is happening on Tuesday, and so on. And it goes until Sunday. Which expression represents the number of people who will know the secret by the end of the day, Sunday? And you have to include the originator, okay? So we know that we're starting with 1 in these expressions. So I'm already going to eliminate C because it doesn't start with that 1 person. So it looks like it goes 1. Then by the next day, we're adding 3. Then the next day, we're adding 9, which is the same as 3 squared. And then the next day, those guys each tell 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And this one's going to be 3 times this number, which is 27, or 3 to the 3rd. So we can quickly see that this has got to be the answer. 1 plus 3 squared up till Sunday for the 7 days. All right. Okay, halfway done. And we got a little bit more than half time left, so that's decent. Okay, next. 18, for which function does the value of y increase at the greatest rate as x increases? Meaning, if they're both going in the same direction at the greatest rate, we're talking about the greatest positive slope. That's what we're looking for. This is a negative slope. This is a negative slope. This is a positive slope. This is a positive slope. Which one increases at a greater rate? Meaning, which one is steeper? And we're going with C. Okay? Hard question. Next, now we're in the quantitative comparisons. A means column A is bigger. If I choose B, it means column B is bigger. C, the two are equal. D, there's not enough information to answer. The value of x when y equals 15. If y equals 15, okay, it's 15 equals 4x minus 1. Isolate, we add 1 to both sides. I get 4x equals 16, x equals 4. So the value of x here is 4. The value of y when x equals 4, plug 4 in for x. And we get y equal 4 times 4 is 16 minus 1 is 15. So clearly column B is bigger. Actually, I'll write a B. Okay. Next, Rosa received $1.48 in quarters, dimes, and pennies. Smallest number of coins that Rosa could receive, meaning we got to have the most amount of big coins. So I can have 5 quarters to get me $1.25. Then I can have 2 dimes to get me $1.45. And then I can have 3 pennies to get me $1.48. So 5 plus 2 plus 5, which is 10. So in this case, column A. I'll put it like this and like this. Okay, that's the smallest amount unless I made a mistake, but I'm pretty sure that's correct. Column A. Okay, let's do this one. Square root of 9 plus 16. Add these together and we get square root of 25. Order of operations, square root of 25 is 5. This one is, we have to do it separately. Square root of 9 is 3. Square root of 16 is 4. So we take the square root first, add them together, we get 7. Therefore, B is bigger. What about this one? Parentheses means it's -3 times -3 times -3 times -3, which is positive 81, because a negative times a negative is a positive, times another negative is a negative, times another negative is a positive, like a light switch switching on and off. This one's different. This is 3 times 3 times 3 times 3, which is 81, and then that negative just kind of hangs out there and tags it. So column B, even though it looks like they might be the same, column B is bigger. The original price of a bicycle is $100. The amount saved after 20% discount. So 20% of 100, you could probably do that mentally, is $20, so it's 80. The amount saved after two separate discounts of 10%. Now that seems like this would be the same, but let's think about it like this. First we take 10% of 100 off, and that becomes 90. Then we take 10% of that. Well, 10% of this, a shortcut is you just move the decimal over once to calculate 10%. So 10% of that is 9, and the final production is 81. So this is actually worse. This is actually, the amount saved is actually 19. The amount saved here is 20. Okay, so not these. So which one is bigger? It's column A. To get from Springfield to Wakefield, Miss Swift can take a road back for 20 miles at an average speed of 40 miles per hour. Okay, so 20 miles at 40 miles per hour, and that means this takes a half an hour or 30 minutes. Right, because if we're going 40 miles would be 1 hour, 20 miles is half of that, would be half an hour. Or he can take a high road for 25 miles at an average speed of 50. Same thing, 50 miles per hour. So he'd go 50 miles in 1 hour. He needs to go 25 miles. 25 would be a half an hour. So guess what? It's the same. 30 and 30. Okay, the slope. How do we calculate slope? We isolate y, put it in the slope-intercept form. So I'm going to subtract 4x from both sides. I get -2y equals -4x plus 10 divided by -2. Y equals -4 divided by -2 is 2x minus 5. Okay, so my slope is this value right here multiplying the x, so my slope is 2. The slope between these 2 points, to calculate slope, we stack the coordinates 2, 8, 4, 4, subtract down and put the difference of the y's on the top. 8 minus 4 is 4, 2 minus 4 is -2 equals a slope of -2. So which one's bigger? 2 or -2? 2, clearly. Okay. So that means A is bigger. That's how we rock the quantitative comparisons. Next, all right, so we're doing really good on time because we only have to go to 32 and we got 13 minutes left. To predict two groups of people would vote on a proposal, samples were surveyed, and then we vote yes or no. The percent of each sample surveyed and the number yes, no responses are shown. The results can be used to predict how many people will vote for and against the proposal. The predicted number of yes votes when all members in group A vote. All right, so check it out. This is only 25% of the total people voting, meaning it's going to be 4 times this amount will be the total. So if we got 18 yes right now, when we have the entire people vote, we assume that's going to quadruple. So we quickly do 4 times 18, which is 72. Okay. The predicted number of yes votes when all the members in group B vote. Right now we got 20 voting yes. But that's only we only got half of these people, so it's going to double, right? So this one's going to go from 20 to 40, so column A is bigger. Okay, in the diagram above, all angles that appear to be right are right angles. The distance Mary saved by taking the shortcut instead of her normal route. Let's see. She didn't save anything, actually, I'm pretty sure. So it's like she goes 500, 500, 500, 500. That's 2,000, right? In this case, I don't think she saved anything because she goes 500. Oh, wait, we don't know this value. Hold on. It doesn't. See, the problem is it doesn't list a value here. It should have. And it doesn't list a value here. So 500. Hold on, let me think. Oh, no, it doesn't matter because this whole thing is 500. So this has to be 250. This has to be 250 because this whole thing is. Oh, this one it doesn't show. Actually, I'm sorry. This is a little tricky because if we assume it's the same distance, which I don't know if we can. I actually think this might be a mistake. I can vaguely remember this. But if it's basically, if this is 500, it's the same because it's 250, 750, 1250, 1500, 1750, 2000. But we don't know. So they're actually the same. So this is 0. So column B is technically bigger. However, it doesn't list this. So I'm actually inclined to say D, okay? Because it doesn't tell us, it doesn't tell us like this distance and this distance. So because of that, I'm going to go with D. But this, I can't remember if that's actually what they wanted you to pick, but that's what it should be for this one. And then we'll double check the answers. Carrie is driving from town A to town E. She must travel through towns B, C, and D in order to reach town E. Carrie has just arrived at town C. So she's here. So total number of carrier miles has driven. So she's just arrived at town C, so she's driven 135 plus 55, which is 190. And how far she has left to drive, which is 110 plus 86, which is 196. So B is bigger. Next. Area of the shaded portion, area of the unshaded portion. Okay, how do we do this? So if we look, okay, let me think about this for a second. This triangle, hold on. Like my feeling is the shaded is definitely bigger. I know there's a way to do this. Hold on. Just blanking for a second. Okay, I'm just going to have to count it up, I think. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this shaded is 12, 12, and 12. And this is 1, 2, 3, 4. Okay, so I'm counting those halves, and then that's it. And then so this one is 12, and this is clearly 4. So clearly, oops, so small. It's hard to write. So it's clear the shaded is way bigger. It's like 30. The shaded is 40. The unshaded is 4, 4, 4. 12 is 24. So this is way bigger. You could kind of tell from the way it looked, but all right. The spinner is divided into 8 equal-sized parts. For any one time, the spinner spun the probability of spinning an odd number. So odds are 1, 3, 5, and 7. So 1/2. For any time the spinner spun the probability of spinning a number less than 5. So less than 5 is 4, 3, 2, and 1. Okay, because it doesn't include 5. That's also 1/2. So there's C. It's equal. 9 cards numbered 1 through 9 are put in a bag. Probability of choosing an even number. So let's write them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Even number is 1, 2, 3, 4 out of 9. Probability of choosing an odd number is 1, 2, 3, 4, 5 out of 9. It's B. Probability is the number of ways to get what you want over the total. And that's it. That's how we're setting it up. Okay, so B is 5/9. And then last but not least, R and T are points on a line L. S is not shown. Oh, it's between R and T, so S is here. Okay. The distance between R and S, this is D straight away because it doesn't say where S is. S could be here, and this could be bigger. S could also be here, and then this one could be bigger, ST. So this is a clear D1. Okay. So like I said, I'm pretty sure these are all good. The only one that's iffy is this one because I actually think they made a, unless I'm totally wrong, let me just make sure. Yeah, because that's the thing. We just don't know. She had to go as far this way. If it's not D, it's in my opinion, it's a mistake on the way they've designed it. But like I said, it's either D or B because this is if this is 500, this distance here, then she saved nothing. It's the exact same. Okay. All right, let's take a look. I'm going to stop the timer and we're going to grade it now. I just really want to check 27. Oops, here we go. I think the answers are up here. Here we go. All right. Quant. Let's do it in purple. Okay. And we'll zoom out a little bit. Okay, AACA. AACA. And then we've got 5 is CBDD, CBDD. Then we got 9 is BCCB, BCCB. Okay. 13 is CACA, CACA. 17 is D. 18 is C. Oops. $19 is B. Okay, so BA, BBA. BA, BBA. 24, hold on. I just realized that. So they did choose 27, a different answer. So we'll talk about that in a second. 24 is C, 25 is A. 26 is A, 27 is. So 27 is, they're saying it's B, which I completely disagree with, and I'll go over that one more time in a second. 28 is B, 29 is A, 30 is C, and then 30 is C, B, D. Oh yeah, C, B, and then D. Okay, so the only tricky one is, and I don't think this is going to happen on the real ISEE, where they give a question like this that's not crafted correctly, in my opinion. But look, here's the deal. So they're saying D is not correct. They're saying it has to be B, which I said was essentially, that was the only other option. Well, let me think about this for one more second, because theoretically, okay, the greatest, so, because there's nothing here. I mean, this could be 1,000 and 1,000. This could be 1,000 and like 750. We don't know because there's no labeling here. And then she wouldn't have saved anything. Then this would be like negative. Okay, then let's say if this were 251, 200, and then this would be 251, coming down, and then back 1. So then she would have saved like 5. Hold on. I don't see. Like the smallest this distance could be is 1. I'm just trying to make sure I didn't oversimplify it. And the greatest this could be is 2, and then this would be 251, right? So in this case, and then this would be 250. So in this case, it'd be 250, 750. So she would have saved 249 and then another 249. So she would have saved a ton. So in that case, A would be correct. Right? Like I can show, because they didn't label those distances, I can find ways where A will work. And then of course it's easy to see where B will work if, as we calculated before, when we can say she saved nothing, if this is still 500 and this is still 250, then it's the same. But that's my issue. So I think they made a mistake in labeling. I know they made a mistake in labeling this diagram because there is simply not enough information. But I don't think you have to worry about anything like this. This is, like I said, an old practice as they've been using for years and years, and it is what it is. All right, I'm going to run to the board now and see if we got any questions. Okay, can you give the Indian IAT because it exposed me to... Yeah, if you want to send it to me, I'm happy to check it out. All right, that is it. This is our first installation of ISEE Middle Level Math. Thank you guys so much for joining. I hope you guys learned from this, and I hope it's helpful. If you do have any additional questions, feel free to email me at huzaifa@scalarlearning.com. If you like what you see, click that like button. I hope you do. It really helps the channel big time. And if you want to see more, subscribe as always so you can get more up-to-date live streams and other math goodies. That is it, and I wish you all the best of luck. Take it easy.